Hello, everyone. Today is November 3rd, 2025, the 1 year anniversary of my most popular video, the review of the ANENG ST170 AC current clamp multimeter. So far, I have racked up over 3,000 views and counting. And my video about this little multimeter right here is actually the most popular video on any platform about this multimeter, even beating out ANENG's own video about this multimeter. However, unfortunately, it has batteries in it, which are still quite fresh, and when I turn it on, it doesn't do a thing. If I go up to the higher ranges, 2 amp, it flashes for a second and is doing some weird stuff. 200 amp, it's doing some stuff, but it's not really doing anything. It's has a percentage thing right there, and if I just hold it up to some sort of stuff, sometimes it counts up. It's just not working at all. And so, unfortunately, this thing is now dead, and it has actually been dead for over a month. But never fear, I found a replacement from the thrift store of all places. The Fluke 801A digital benchtop multimeter. This thing is, it's very impressive. This is a mains-powered multimeter, as you can see by the mains input connector over there. But this thing also has a small battery pack in it that allows you to power it even when not connected to mains. As you can see, it still turns on and doesn't really fade out. Unlike the typical multimeters, which have a range switch like this one has buttons which allow you to select any sort of combination you want. You press volts, milliamps, or kiloohms, and then you can select ranges through the gray buttons. For some reason, the voltage range only has 5, while everything else has 6. And also, you might notice that it has kiloohms/S, and S equals 1 over ohm. This is kind of interesting because they, for some reason, decided to allow this thing to not only measure ohms, but also Siemens. And Siemens are the inverse of an ohm, so they are a measurement of conductivity and not resistance. And to activate Siemens, you would have to press 2 of these buttons at one time. Now, this thing, it's very nice. It's a Fluke multimeter. It even says made in the USA down here, not any of that Chinese AliExpress rubbish like this thing. Anyway, I do have some minor quibbles with this thing. First of all, the display. The display is usable, but something tells me that it's on the brink of death because LCD displays, they age kind of quickly, and I mean, when it's not connected to anything, it's all right, but you might notice that there aren't even any borders between the segments, and if I change the viewing angle, you might be able to see some of the traces that actually bring power to the segments light up, or I guess darken, because this is that type of LCD display, and something tells me it's on the brink of death. Also, this thing does not have a proper continuity setting. If I just get the probes that it came with, these clip-on style probes with the banana connectors at the end. I can just stick one in common and one in volts, kiloohms, Siemens, and I can, it's already set to kiloohms/Siemens, and if I, for example, set it to a diode test mode, the 2 kiloohm range, and I connect these up, it doesn't say anything. It just really says 0. It doesn't beep, is what I mean. So that's kind of annoying. And of course, the LCD is kind of bad. But I feel like there is one big issue with this thing, and it is right here on the panel. Let's zoom in. So here is the 10 amp max jack, and if I zoom in, unfused. So if you pass more than 10 amps through it, significantly more than 10 amps, it is possible that the multimeter could potentially be destroyed from an overcurrent event. So that is unfortunately quite disappointing that it's unfused. And also, the fuse holder for the milliamp jack is quite strange. Let me go ahead and get a suitable item to open the milliamp fuse jack. Here is my tweezers, and the back end can indeed open up the milliamp. You just press it in and then let it go, and then you can take the whole thing out. And maybe I need to properly grab it. And wah, 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 wah. I have jammed a piece of copper wire into the fuse holder because the original 2 amp fuse in the milliamp range has blown. This was the original fuse, and as you can see, the wire in there is completely gone and is just a couple of little pieces clinging to the glass. So this thing wouldn't work in the milliamp range with a fuse, and I do not have a 2 amp fuse of this size. It's quite a bit bigger than an ordinary fuse, but I really hope that I will be able to get some 2 amp fuses that will fit in this holder soon, because trust me, I do not want to use a giant piece of copper wire as a bypass for the fuse holder. In fact, this might actually be the reason that it was donated. Somehow this 2 amp fuse got blown, and they must have think it was completely broken, so they decided to donate it for some reason to my thrift shop. So that was kind of strange that they decided to donate a broken product. This thing, it normally costs about $45, but I actually got a pretty decent deal on this. This sticker that my thrift store likes to put on electronics projects, it just says tested, puts the date on it, and it cost only $25, 25 US dollars, and that was very cheap for something like this. Anyway, let's go ahead and hook up some regular probes and make some measurements. These are the, funny enough, the probes that came with my old ANENG multimeter, but I have cut off the sleeves that they will fit into the banana jacks of this multimeter. So I can put that back a little bit, and I can measure some things. So let's go ahead and get a battery. Here is a fully charged lithium-ion battery. Let's position this thing so that hopefully the screen will be a little bit brighter. Let's turn this thing on, set it to the volt range, and set it to the 20 volt range. And now if I measure this thing, as you can see, it is about 4 volts. So that is quite normal for a mostly charged lithium-ion battery. Let's also go to the milliamp range and see if we can get a suitable situation in which I can measure milliamps. Here is a suitable testing setup. I have a small breadboard power supply set up over here connected to a 12 volt power supply, and I have a little LED over here. And if I complete the circuit by connecting this little part of the LED to this little thing, then the LED should light up and it will show a current. It's on the 20 milliamp range, and let's see what happens. Nothing, apparently. Alright, that's better. So now I should be able to measure the current, and it still doesn't work. Hold on a second. That should have been quite obvious for me. I just had to switch it from the volts, kiloohms, Siemens jack to the milliamp jack, which also doubles as a fuse holder. And so now I can probe one probe from here to here, and it shows a current of about 9 milliamps or so, 8.8 milliamps. All right, so now let's try the 10 amp range, and I'm going to go ahead and get a single AA battery. Not even going to bother pausing for this one. Now, let me go ahead and get this breadboard thing out of the way, and I will hook up it like this, and let's see what current the battery can supply. No current apparently, although I might have to set it to the 10 amp range for it to work. So it can supply about 1 amp. And this is just about a short circuit because the 10 amp range has a very low resistance. And if I make a good connection, it shows slightly a bit more this time, so about 1.3 amps. Let's try a different battery, which is probably in a different state of charge, and it'll probably show something slightly different, 0.7 amps. The funny thing, I can probably just set it from the 10 amp range to the milliamp range and put it in the 2000 amp range, so this will be able to give a more accurate representation of the current. Only 500 milliamps in this case. I think the resistance of this is slightly higher, and it's limiting the current in that way. So now let's try kiloohms. So let's, or just regular ohms, and I'm gonna go and get a 1 ohm resistor. And let's stick the probes into the holes and see what resistance we get. This will be slightly more than 1 ohm because these probes are not the best and have some resistance associated with them. Oh, look at that. If I do something funny with it, the traces end up laying up with the display there. Probably not the best for it, so let's go ahead and switch from milliamps to volts, kiloohms, Siemens. And I get a resistance of about 2 ohms, which is quite a bit more than 1 ohm, but I will fault it to the resistance of these leads, because if I just tap them together, it already shows 1 ohm. Let's see if I can do any better with the leads that came with this multimeter. And hook them up to the power resistor. Alright, that's a bit better. It shows 1.2 ohms, although that 0.2 ohms that's being added on there probably is the resistance of these probes and the banana jacks and stuff. Anyway, let's try the diode test range, which also doubles as a 2 kiloohm range. So let's go ahead and get some diodes, like for example this ordinary silicon diode here. It should show a voltage drop of about 0.5 to 0.6 volts. It's quite a high voltage drop, about 0.8 volts, but that just might be, I'm not really sure why. Let's go ahead and try this other diode. Maybe because this thing operates at a bit higher current than most normal multimeters. This one also shows about 0.75 volts voltage drop. Let's try a Schottky diode next, which will be a bit hard to fit into the probes, and it should show a lower voltage drop. 0.172 volts, that is quite a low voltage drop and indicates that this is indeed a Schottky diode. And let's also try an LED, because a lot of modern multimeters not only light up the LED, but also show the voltage drop at the LED at whatever current the test operates. And unfortunately, even though that it's connected, it doesn't show anything. And I think this isn't the right polarity. If I turn out the lights, yeah, that LED appears to be very slightly glowing, but it isn't registering anything on the multimeter. Now let's try the one last function this thing has, Siemens. So let's press both the buttons at the same time, and now this is the 2 millisiemens range. So let me go ahead and get a resistor. Let me see if I can find a suitable one here. Here is a bunch of 220 ohm resistors wired in parallel to create a roughly 30 ohm resistor. So let's go ahead and hook this thing up and see what kind of conductivity this thing has. And apparently it has too much for the multimeter to measure. So let's instead try a resistor with about 10 times the value, 330 ohms. And it still goes over range. How about this one, which is about, actually I'm not completely sure what the value is because that is a very weird value. Let's find a 10 kilo ohm resistor and see what this thing shows up as. It shows about 0.1 millisiemens. And that's just on the millisiemens range. And let me go ahead and get a calculator and see if this is accurate in ohms. Here's a calculator, and let's turn this thing on. First, I will try to calculate siemens just from the resistance of this resistor, which is about 10 kilo ohms, of course. So, 10 kilo ohms, 10, 1, 2, 3, yeah, of course, 10 kilo ohms, 10,000 ohms. And then what we need to do is clear this because it's actually 1 over 10,000 ohms. And indeed, it says 1 with four zeros before it, so it's basically 0.0001. And indeed, it shows up as about the same because this is millisiemens and not full Siemens. So this Siemens range does appear to be quite accurate, even though that there are only 3 Siemens ranges, while there are 6 ohm ranges. So anyway, that's about all I have to say from this absolute beefy Fluke 8018 digital multimeter.